I'm looking for pound notes, loose change, bad checks, anything. Give me some money. Give me some money.
Okay, here we go, homework 2. Now, I'm going to work through the exact problems you'll be doing in the homework. And so this will be a simple exercise of just following along with me and doing what I do and learning the formulas, and hopefully through that process you'll get a better handle on these concepts. So we're going to work through 4 worksheets here. We're going to deal with some foreign currency cross rates. We're going to deal with triangular arbitrage. Got a couple worksheets on that, and then we've got one on interest parity. So let's go to cross rates. Now, I downloaded from Bloomberg Currencies recent values for some major currencies. We have most of these expressed in terms of the US dollar, a few in terms of the Japanese yen, then a couple of cross rates. So what we want to do is create a complete cross rate table for the selected currencies. So we're going to have these currencies here on the vertical priced in units of these currencies here on the horizontal. Now, a lot of these are going to be given for us, so it'll just be a matter of plugging them in the table. But then others we're going to have to calculate based on doing some inverses or by doing some proportion math to find cross rates. Okay, so for example, we have the euro in terms of US dollars, and you have to remember how these things work because they kind of oscillate between European and American terms here. So it's the first currency in terms of units of the second currency. So in other words, it's how many of the second currency here for 1 unit of the first. The 1 euro in terms of dollars. A euro costs $1.20. So we'll find that in the table, a euro in terms of dollars priced in this currency. And we'll enter the values to 4 decimal points, 1.2075. All right. US dollar in terms of Japanese yen. A dollar is 106.57 Japanese yen. $1 is 106.57 yen. Okay, what else do we have here? Great Britain pound in terms of US dollars. 1 pound cost $1.39. British pound cost 1.3933. We don't have Australian dollar on here, so we can forget about that. We also don't have Canadian on here. US dollar in terms of Swiss franc. Remember Swiss franc, CHF, Confederatio Helvetica. It's the Latin name for Switzerland. Hey, if you learn nothing else in this class, at least you learn a little monetary trivia. So the dollar in terms of Swiss francs, that's right here. The dollar priced in Swiss francs, it's 0.9085. All right. The euro priced in Japanese yen, it's 128.67 yen for a euro. The euro priced in yen, 128.67. The euro priced in British pounds, 0.8670 pounds per euro, 0.8670. Okay, this is Hong Kong dollar. We're not looking at that one in our little table. Euro in terms of Swiss francs, we have that, 1.0971. So it's the euro in terms of Swiss francs. It's the euro in terms of Swiss francs, priced in Swiss francs, 1.0971. And then that's the Swedish krona, so we don't have that either. So that's what we can get from the data from the newspaper, so to speak, from the website. Now what we need to do is we can take everyone that we have here and we can invert them to find those direct cross rates. But then we're still going to have a few remaining cross rates, and I'll show you how to work the proportion math on that. Okay, so we've got the pound in terms of dollars. What is the dollar in terms of pounds going to be? Well, that's going to be the reciprocal. So it equals 1 divided by that price. So a dollar is going to cost 0.71 pounds. All right, and you'll notice if by now, if you haven't, that I've got these kind of color matched here. I've created the matrix color matched, so we know that these prices here are reciprocals of each other. They have a matching color. All right, what else can we do? We've got the euro in terms of US dollars. Well, let's do the US dollar in terms of euros. That's going to be 1 divided by the dollar price of euros. So a dollar US dollar costs 0.82 euros. All right, so we got those here. All right, we got the euro here priced in terms of Japanese yen. What would the Japanese yen in terms of euros be? Well, that would be 1 divided by the Japanese yen price of euro. So it would be a Japanese yen is priced at 0.0078. So not even 1 cent, 1 euro cent, Japanese yen. You'll notice that the Japanese yen prices of all the other currencies are going to be high because it's a currency with a very low unit value. Okay, what else can we do here? We've got the euro priced in Great Britain pounds right here. We can do the British pound priced in euros right here. Equals 1 divided by the pound price of euros. So a pound costs 1.15 euro. All right, we have the dollar priced in Swiss francs here. That's from our table, 0.908 Swiss francs per dollar. Now we can do the Swiss franc in terms of dollars. That's going to be 1 divided by the Swiss franc price of dollars. So a Swiss franc is worth $1.10. That's what that's telling us. And then finally we have the euro priced in Swiss francs, 1.09 Swiss francs per euro. So up here we can do the Swiss franc in terms of euros, equals 1 divided by 1.0971. So a Swiss franc costs 0.91 euros. But here, oh, and I just realized that we were missing one reciprocal, so we can do the Japanese yen in terms of the US dollar. It's going to be 1 divided by the yen price of the dollar. So the Japanese yen is worth just under 1 cent US, 0.009. Okay, so we have the yen in terms of dollars and the dollar in terms of yen. Okay, so that's as far as we can go filling out the matrix with just the direct quotes here and then our simple reciprocal cross rates. So moving on here, and we'll just keep moving left to right, top to bottom in the table. So we're going to have the Japanese yen price of Swiss francs, or Swiss francs in terms of Japanese yen. So that looks like this. It's the Japanese yen per Swiss franc, per 1 Swiss franc. So that's like when you write it in ratio form like this, that's kind of how you want to read that. It's the Japanese yen per Swiss franc. And we don't have that, again, we don't have that directly, but we do have both of those currencies, the yen and the franc, priced in dollars. So I have the dollar price of francs, I have the dollar price of yen right here, and then I have the yen price of dollars right here, and the Swiss franc price of dollars right here. Well, 2 sets of those ratios will get us a conversion factor here. So here's what we can do. We can say this ratio is going to be equivalent to Japanese yen per US dollar times US dollars per Swiss franc. Notice what's going to happen with this set of ratios. The dollars are going to cancel, and then we're left with Japanese yen per Swiss franc. Okay. Well, so what are these values? So what is the Japanese yen per US dollar? How many yen per dollar? That's this one right here. So that's a 106.57. I'm just going to write down what we're doing here. Of course, we'll have Excel do the math. Times US dollars per Swiss franc. US dollars per Swiss franc. That's going to be this one up here, right? The Swiss franc priced in US dollars. That's that one, 1.1. Okay, so this is going to be just a little bit more than 106, and that makes sense if you think about, remember, the Japanese yen has a low unit value, so all these numbers here in the Japanese yen column are going to be rather large numbers. So let's go into that cell then and do that math. We're taking the Japanese yen per dollar, which is this, times the dollars per Swiss franc, which is that. So there we go, 117.3. And then the procedure is going to be the same for all these remaining cross rates, but I'm going to go ahead and walk you through it because it's complicated and it's hard to keep track of what you're doing. So just follow along with me and you can do what I do and you can get full credit on this. Now, let me warn you, I forgot to mention this earlier, that you can't get full credit on this assignment by just plugging in the numbers I get, because the way I'm grading this is that most of the points are based on did you use the formula. I have ways of checking very quickly and efficiently whether you use the formulas I'm using and not just plug in the numbers. So if you plug in the numbers, you only get partial credit. Purpose of this exercise is twofold. One is to help us to think through what's going on with exchange rate situations and exchange rate logic. The other one is to hopefully get really good at Excel. So if we accomplish one of those things, I'll be pretty happy. Okay, so now moving, continuing here left to right, we need the Swiss franc in terms of British pounds. So we need British pounds per Swiss franc. And again, we'll use dollars because we have everything in dollars, so we'll use both of those per dollar. So do I have Great Britain pounds per dollar, British pounds per dollar? That's right here, 0.7177. And then I have dollars per Swiss franc. Dollars per Swiss franc, 1.1, right there. Just kind of round that. And then remember, the dollars part of this is going to cancel. And then I'm left with pounds per Swiss franc. So let's try that in the matrix. Equals pounds per dollar times dollars per franc. Okay, moving right along. Now we're down here to the second row, and we need Japanese yen per British pound. Japanese yen per pound. I have Japanese yen per US dollar, and I have US dollars per Great Britain's pounds. So what's Japanese yen per dollar? That's going to be this one right here. So that's the 106. And then what's the dollars per pound? Dollars per pound is right there, 1.39. All right, so let's let Excel do the math there. Equals, that's that yen per dollar cross rate, and then here's that dollars per pound cross rate. Okay, so moving along, and I hope you're getting the hang of this. Now we need the price of the yen in terms of pounds. So we need the Great Britain pounds per Japanese yen. And again, we'll reflect both of those back to the dollar. So what is the pound price of the dollar, pounds per dollar, times the dollar price of yen. So pound price of the dollar, that's this right here, 0.71. And then the dollar price of yen is going to be this one over here, the yen in terms of dollars, 0.009. And this is going to wind up being a very small number, and of course this is going to be true for everything for the yen priced in all the other currencies, because the yen has a really small unit value. So when we price 1 unit of the yen in other currencies, it's going to be a very, very small amount of those currencies. So the pound price of the dollar times the dollar price of the yen. Oh, and I just see here we missed one for the British pound. So let's do here pound in terms of Swiss francs. So Swiss francs per Great Britain's pounds. And here, of course, we're going to do the Swiss francs per dollar times dollars per pound price. So what's the Swiss francs per dollar? That's this here, 0.908. Just call it 0.9. And then the dollar price of pounds, dollar price of pounds is right here. Let's just call it 1.39, because of course I'm just showing you what I'm doing, right? Excel's doing the math. We always want to use Excel's cell reference for the actual math. Excel will never make a mistake unless we plug something in wrong. And then again, Excel doesn't really make a mistake. We just told Excel to do the wrong thing. It's kind of like that old adage, Chuck Norris doesn't dial the wrong number, you answered the wrong phone. So let Excel do the work and just make sure you're telling Excel what to do. Okay, so there we go. We've got 1.26 Swiss francs per British pound. Okay, we're getting close. Looks like we're down to the last one. What is the Swiss franc price of Japanese yen? Swiss francs per Japanese yen. And of course we'll do this, Swiss francs per dollar. What is the Swiss francs per dollar? That's back over here again. It's a 0.9 times dollars per yen. And where's our dollars per yen? That's right here, 0.009. Right? So let's have Excel run that math. And there we go. Okay, so that's how you do cross rates. Now, fortunately, we can look at sites like Bloomberg or the Wall Street Journal or any number of other newspapers or financial news websites, and they'll give you a cross rates table if you're interested in cross rates. But again, hopefully this exercise has helped us kind of understand how to calculate that and then how to think about exchange rates when we're in a world of many, many different currencies. All right, now if that wasn't challenging enough, here's one that'll be a fun exercise. So this one's arbitrage, and I have worked out a cross rate table for us up here because we're going to find that that's very useful. So I did some implied cross rates. We've got 3 currencies. We've got an exchange rate for each one in terms of the others. So you might recall from the lecture, this was a few weeks ago now, this was a triangular arbitrage situation. So here's our scenario. It says you are a currency trader. Given the current rates in the top left table, so that's the data right up here, work out possible triangular arbitrage scenarios and calculate what arbitrage profit, if any, is possible if you start with 1 million units of any of the 3 currencies. Now, this will be pretty straightforward as long as you follow along. Again, it's kind of a paint by number, and we'll see how the arbitrage process plays out, and we'll also hopefully get pretty used to running formulas in Excel. So there's going to be a total of 6 potential trades that we could work out here. And if you think about, remember, triangular arbitrage, and we have Swiss francs per US dollar. So let's just write down these 3 currencies on the triangle. We have francs, Swiss francs. Then we have Australian dollars per US dollar. So we have Aussie dollars. And then we have Australian dollars per Swiss franc. So then we're going to have US dollars on the 3rd leg of the triangle. Okay. Why are there 6 potential paths for this arbitrage trade? Well, you think about, you could start at any of the 3 points on the triangle. So you've got 3 possible starting points. But then from those starting points, you could go either clockwise. So in this example here, we started with Swiss francs. We traded those for Australian dollars. We traded the Australian dollars back for US dollars. And then finally converted the US dollars back into Swiss francs. So that'd be one possible kind of loop of the arbitrage journey. Now, we could also start with Swiss francs and move the other way. So we could start with francs, trade them for US dollars, trade those US dollars for Australian dollars, and then finally convert the Australian dollars back to Swiss francs. So starting here, we had 2 possible journeys, clockwise and counterclockwise. And then we could also start here, of course. We could also start here. So we have 3 starting points and then 2 directions of movement. So that gives us 6 total scenarios, all of which I kind of have laid out for us up here in this table. All right, so you'll notice how I've set this up. We're going to start with the US dollar. That's going to be kind of scenario 1 here. And then we're going to we could start with this US dollar, move into the Australian dollar, move into the Swiss franc, back into the US dollar. Or we could start with the US dollar, move into the Swiss franc next, move into the Australian dollar, move back into the US dollar. Okay. Now the question is there an arbitrage profit opportunity by taking that journey? And we're going to ignore the bid-ask spread and transactions costs here because that just makes things too complicated. It's good enough for us just to think about this total process. So here's our rates, and here's our cross rates. Now the reason I've calculated the cross rates for you, I don't need to make you, I was thinking about making you do it, but I don't think I need to make you do it again after this grueling exercise over here. But the reason it's going to be very useful to have the cross rates is because it gives us an easier path to do some of these conversions. So start with $1 million every time. That's going to be up here kind of in this top row. $1 million here, a million units of the currency. So 1,000,000 Swiss francs, 1,000,000 Aussie dollars. Here we're starting with, in scenario 1, US dollars. So we're going to take $1 million US dollars. I'm just going to tag that cell reference. And we're going to convert those first into Australian dollars. So I want to multiply that by the price of US dollars in Australian dollars. So that's going to be the US dollar Australian dollar exchange rate. You get 1.82 Australian dollars for each US dollar. So I kind of changed the wording here too so you can follow. For one of these, for one US dollar, you get this many of these, 1.82. Okay, so that gives us 1.82 million Australian dollars. Okay, now in the next loop, in the next sequence of the journey here, we're trading those Australian dollars for Swiss francs. So we're starting with that many Australian dollars. And now we need to say what is the Swiss franc price of an Australian dollar. So here, an Australian dollar here, priced in Swiss francs is that, 0.87. So now we're at about 1.59 million Swiss francs. Okay, and then the final leg of the journey is trading those Swiss francs back into US dollars. So I started with Swiss francs, and we're trading them back into US dollars. So what is the dollar price of Swiss francs? A Swiss franc is worth $0.62 right there. Enter. And I wind up with $996,000, $997,000 roughly, compared to the million I started with. Was that a profit maker? No, that's going to be a loss maker. And here's the function we'll use. I have the formatting already set. We just have to run a simple if function. Equals if parentheses. This value here that we wound up with is greater than the value, the $1 million that we started with right up there, C8. If that's true, so that's our logical test completely. So then we have a comma, and then the next part of an if function is going to be value if true. Important, this has to be in quotes because it's going to be a text output. We're going to say profit if it's true, end quotes, comma, and then the value of false component, we're going to say loss, again, in quotation marks. Close the parentheses to end the function. All right, that's obviously a loss. You can see that with your own eyes, very easy. Okay, well now from here on out we can just copy and paste that formula for every remaining potential scenario. Okay, so now we're starting with the $1 million again, but now converting them to Swiss francs first rather than Australian dollars. What is the Swiss franc price of dollars? There it is right there in my cross rates table. So with the $1 million I get 1.6 million roughly Swiss francs. All right, now convert those into Australian dollars. So take my 1.6 million Swiss francs, convert those into Australian dollars. What's the Australian dollar price of Swiss francs? There it is right there. Okay, and then, so we get 1.8 million Australian dollars, take our 1.8 million Australian, and come back to US. So what is the US dollar price of an Australian dollar? There it is in my cross rates table, F4. So that gives us 1,003,065 US dollars. Hey, and we started with $1 million, so is that a profit or a loss? Well, we can see that that's a profit. Let's copy and paste. I'm using Control C to copy and then Control V to paste. And of course, 1.003 million is greater than 1 million, so that'll show profit, and I've got that formatted to show green. Now the final thing I want to do is say, what is the profit in US dollars? Well, we started with US dollars, we ended with US dollars, so this one's pretty easy. It's just going to be the amount of dollars we ended with minus the amount of dollars we started with, 3,064.73 to be precise, because I'm having Excel round these to the nearest whole dollar. Okay, now let's start with Swiss francs, same procedure. We're going to start with 1 million francs this time. So we have 1 million Swiss francs. And we're going to start by converting them to US dollars first, then Australian dollars, then back to Swiss francs. So what is the US dollar price of Swiss francs? The US dollar price A Swiss franc is worth $0.62. Okay. Then we're going to take that $626,000 and convert those into Australian dollars. So that's a starting amount. And then what's our Australian dollar price of US dollars? The US dollar in terms of Australian dollars, G5. So it gives us 1.1 million Australian dollars. Okay. And then our final leg of this journey, we're going to take that 1.1 million Australian dollars. We're going to say, what's the Swiss franc price of Australian dollars? The Australian dollar priced in Swiss francs, right there, H4. And we wind up with 996,945,000 Swiss francs. And of course, we can Control C, Control V, our profit or loss statement test. That's a loss again, obviously. Okay, now let's try the other option here, starting with Swiss francs. We first convert them to Australian dollars, then back to US dollars, then back to Swiss francs. So we're starting with our million Swiss francs, and now converting them to Australian. So what is the Australian dollar price of Swiss francs? Hopefully you're seeing why the cross rates table is so useful to think through this procedure. And by the way, there's people doing this every day. People are looking for the discrepancies. They're going to have a lot more kind of day-to-day knowledge of both the prices and the procedure than we do, because we're kind of painfully working through it in Excel. But at least we can understand the logic of what they're doing, and again, get kind of familiar and comfortable with modeling this kind of stuff in Excel. All right, so we wound up with 1.1 million Australian. We want to convert that back to US dollars now. So what's the US dollar price of Australian dollars? There it is there, F4. It gives us 628,000 US, and we want to take that amount and convert it back to Swiss. So what is the Swiss franc price of US dollars? 1.59. And so here again we get 3,000 extra, but this time it's extra Swiss francs. Let's copy and paste our profit or loss check. Of course, that's a profit. And now we want to convert that back to US dollars. So I'm going to start, notice that I'm going to group this in parentheses first. I'm going to calculate my gain, so what we ended up with minus what we started with. And now, that's Swiss francs. We want to convert that back to dollars. What's the dollar price of Swiss francs? There it is in the cross rate table. Okay, so that's going to be worth $1,918. Okay. So hopefully you're kind of seeing what we're doing here. It's a really consistent process. Start with Australian dollars now. Again, 1 million. And there's two options. We can convert them to US first, and then to Swiss, and then back to Aussie. Or we can convert them to Swiss first, and then to US, and then back to Aussie. So we'll do this here. We'll take our million Aussie dollars. We'll convert them to US dollars. What is the US dollar price of Australian dollars? At 4. That gives us 549,000 US dollars. Want to convert those now back into Swiss francs. What's the Swiss franc price of US dollars? Getting the hang of that cross rates table, right? Now we're going to convert those back into Australian dollars. So 876,000 US. I'm sorry, 876,000 Swiss. What is the Australian dollar price of Swiss francs? There it is right there. And that gives us, hey, notice a pattern here, 3,065 extra, but this time it's extra Australian dollars. So let's again find the profit, which is that minus what we started with. So that's our profit in terms of Australian dollars, but then I want to pull that back to US dollars. So what is the US dollar price of Australian dollars? And there it is. Oh, and by the way, let's copy our profit or loss check function. And of course, that's a profit. Now you can probably guess what's going to happen over here. What's the Australian dollar? We're going to take the Australian dollars, go to Swiss francs, to US dollars, back to Australian. So take our million Aussie, convert them to Swiss. What is the Swiss franc price of Aussie dollars? H4. Now we've got 874,000 Swiss. Convert that to US. What is the US price of Swiss? Right there. 547,000 Swiss. Sorry, 547,000 US dollars. Now we're going to bring that back to Australian dollars. What is the Australian dollar price of US dollars? There it is right there, G5. And we wind up with 996, and of course, a loss. Okay, so that is how triangular arbitrage would work. Okay, there's one trip that makes sense, and that is going from dollars to francs to Aussie dollars to dollars. But you could start anywhere. It's basically one way around the triangle. We could start anywhere there. We could start in Switzerland, go to Aussie, US, back to Swiss. Or we could start in Aussie, go to dollar, Swiss, back to Aussie. But you have to be going the same circuit around the triangle. So there's how triangular arbitrage works out in practice. Now, what's going to happen here? Well, people want to, there's multiple ways this could happen, but what we're going to have is an adjustment of prices, so these arbitrage opportunities will ultimately disappear. We're going to have one of these currencies, or maybe more than one of them, bid up in terms of the other until the arbitrage disappears. So that's the next worksheet. It's called Arbitrage Equilibration. Now what we're going to do here, we don't need to do the whole procedure again, but I didn't want to pre-fill that in here because I wanted you to do this yourself. So what we can do now is, let's do it like this. We will select, I've got some merged cells here, so we'll do this one scenario at a time. I'm going to just copy all of my results. In fact, let's copy the profit and loss part too. So I'm going to copy that whole range, and we're going to plunk it down over here. So exact same results. All the cell references are the same. It's the same table. Copy my results for scenario 2 here. Control V, plunk them down over here. Copy my results here for scenario 3. Control C. Plunk them down over here, Control V. Okay, there we go. So everything's matched up there. And now I want to say what's going to happen to eliminate those profit opportunities. Well, we know these exchange rates are going to change. So how can they change? Well, we could sit here and start plugging in new numbers and guessing. You know, I could say, well, maybe the value of the Swiss franc will go up. I don't know if it'll go up or down per se. I'd have to kind of think that through, but I'll let Excel do the thinking for me. It was 0.597. Let's make it 0.598. Yeah, let's make it let's make it 1.6. And that's making the profit larger, so let's make it go down 1.5. Okay, well, that was way too big of a change, so I don't know what the right change is going to be. Maybe make it just 1.59. There we go. That switched the direction of the trade, but it made the profit smaller. So I'm undoing that. Don't do what I just did. I'm just showing you. We have to find new values until the profit disappears. And that could be a very tedious process if we were just going to guess and check on our own. But Excel can do that for us very efficiently. So here's what I want us to do. We're going to go up here to the tabs at the top here, and we're going to click on the one called Data. And then over here on this ribbon, we're going to come way over here to What If Analysis. We're going to use a really nifty tool Excel has called Goal Seek. So we're going to goal seek and find what value would eliminate the profit opportunity, and we're going to change the value of each currency. So that's what I'm doing, and we're going to plug this value in down below here where I have this table called equilibration. So what I want to do, and I could take any of the results here, but I'm just going to take this first one that was the profit for scenario 1. So I'm going to set the result here. This is going to be cell E15, so that's going to be my first thing I plug into the goal seek. And I'm going to set it now to the value here. You can't use a cell reference. You have to actually type in the value. So to eliminate the profit, we're going to have that set at the $1 million we started with. So that's a 1 and 6 zeros. And the way we're going to do that, first of all, is we're just going to change the Swiss franc value of the US dollar, which is right there in cell C3. Now watch what happens when I press OK. Well, Excel did it so fast we could barely see, but what Excel did was tried several different permutations of the value for the Swiss franc, and it came up with 1.5922. So I'm going to hit OK, and I'm going to type that in down here, 1.5922. And what happened there? A profit opportunity went away. So we re-equilibrated. Well, the value of the Swiss franc was 1.59. I can go back to my previous sheet if I need to remember that, 1.5971. Let's plug that value back in here, 1.5971. So what happened to the Swiss franc there? 1.5971. There we go. Its value is just a hair lower, isn't it? And that is the Swiss franc value of the US dollar. So the US dollar what we would say it's worth just a little bit it's just worth a little bit less Swiss francs. So we could say the US dollar depreciated just a bit against the Swiss franc. I want you to type an explanation in there. You could also say, of course, the Swiss franc appreciated against the dollar. That would cause the same result. Okay, let's think about changing the Aussie US dollar exchange rate. So again, what if analysis, goal seek. And we're going to again set this cell E15. You could pick any of these results. I'm just sticking with that one. Seems like it'll work just fine. To 1 million, 1 with 6 zeros, by changing the Aussie US dollar exchange rate. Okay, so kind of mentally note what that was, 1.8215. And now it's 1.8271. Let's hit OK. Let's write that down, 1.8271. Notice I have these formatted with the currency, with the 3-letter currency codes here. So all you have to do is type in the number. Okay, 1.8271, and it was 1.8215. Let me have these show the proper amount of decimals for us. There we go. It was 1.8215. Let's put that value back in there. Okay, so what we're saying is the dollar, in terms of the Aussie dollar, the US dollar, it was worth 1.8215, and now it's worth 1.8271, a little bit more Aussie dollars. So we can say the US dollar appreciated against the Australian dollar. Or conversely, you could say the Aussie dollar depreciated against the US dollar. All right, finally, let's adjust the Aussie dollar Swiss franc price. And once again, go to what if, go to goal seek. We're going to set this cell equal to 1 million by changing that final exchange rate. It was 1.144, and it's going to go to 1.1405. Let's press OK. 1.1405. It was, let's go back to the other sheet, 1.1440. I'll change this back, 1.1440. So it went down just a hair, again, just a little bit of change. This is the Australian dollars per Swiss franc here, and it was 1.1440, and now it's gone down to 1.1405. So the Swiss franc is worth a little bit less in terms of Australian dollars. So we'll say the Swiss franc depreciated against the Australian dollar. And of course, you could flip that around and say the Australian dollar appreciated against the Swiss franc. Okay, so that's a look at the mechanics of foreign exchange triangular arbitrage. Kind of complicated, but this is what's going on out there. There's enough people doing this to make sure that these arbitrage opportunities, they barely ever pop up, and if they do, they'll go away immediately because somebody's going to jump on that profit. Seems like a small amount of money, but imagine doing that with 10 million or $100 million at a time, and that could add up pretty quickly. All right, let's move to the final worksheet, interest parity. So you'll notice that this is the same kind of model that I set up for the covered interest parity lecture video, the best covered interest parity lecture video on the internet. Hope you agree. And this is a modification of an exercise out of our textbook. So we're going to use the same format and the same model, but a slightly different example. Again, working with US dollars versus British pounds, but things are slightly different here. So let's read through the scenario. The spot exchange rate is $1.50 per pound, and the forward rate is $1.52 per pound. The interest rate is 8% in the US, well, typo there, 5.8 in the UK. Assume that you can borrow as much as $1.5 million or 1 million pounds. All right, first step, determine whether interest rate parity is currently holding. Well, we're going to go through a procedure based on what do we want to do? Well, we want to borrow the cheaper currency, so we want to borrow pounds, convert those pounds to dollars, and then invest the dollars at the higher US interest rate. So we're going to borrow pounds at 5.8, then invest the dollars once we convert them at 8%, and then to make sure we don't get burned by a change in the pound-dollar exchange rate over the time where we're earning that 8% on the US dollars, we sell those dollars forward back for pounds to lock in that exchange rate. So that's why the spot and the forward rates are relevant here. And remember, this is an arbitrage where we're arbitraging both over these two sets of prices here, spot and forward rates, and over this set of prices here, interest rates. Interest rates are the prices of money, right? These are the prices of money in terms of foreign exchange, and this is the price of money in terms of time, so to speak. So we've got kind of a multifaceted arbitrage situation now. Okay, so then we're going to say if interest rate parity is not holding, work out the covered interest arbitrage opportunity. Well, we'll work out the opportunity and see if there's profit, basically. If there is profit, parity is not holding. If this is 0, then we'll say it is holding. Explain how IRP will be restored as a result of the arbitrage activities. That's, of course, if there is a profit opportunity. Hint, there will be. And so what we'll do is we'll tweak the spot and forward rates a little bit until we see that the arbitrage opportunity is gone. All right, so what do? We're going to borrow low, again, borrow pounds, and lend high. Pounds only cost 5.8% to borrow. Dollars pay 8% to invest or lend. So I'm going to start with 1,000 pounds. We're borrowing them at this rate. So what we're going to owe in terms of pounds, and we're going 1 year up. The textbook actually had this on a 3-month basis, but that requires a bunch of extra work. So I just said we'll stick with a year. Keep the math really simple. So we're borrowing 1,000 pounds, and what we're going to pay, we're going to multiply that times 1 plus the pound interest rate. And technically this is to the first power because the n is 1, but we can just leave that off. We could do this for multiple years, but keep it simple. So we're going to owe 1,058 pounds at the end of the year. All right, so once we invest the dollars and convert the dollars forward and sell them back, we have to come up with more than 1,058 pounds. Okay, so that 1,058, that's the amount of pounds that we're going to owe in 1 year's time. And actually, I want to make that negative. So I'm going to put a minus sign somewhere in this function just to remind me that we owe that. It puts a minus sign before the pound symbol there. I kind of don't like that. I like the one that makes it red or puts parentheses on it, but that's okay. Well, remember, that's negative. That's what we owe in a year. Okay, so to get the 1,000 pounds. So we got to exceed that. We got to come up with more than 1,058 pounds after the rest of this procedure. So let's check and see if that works out. So the next thing to do is say, okay, what's going to be the proceeds of the $1,000 converted, of the 1,000 pounds converted to dollars? Well, how many dollars did we get? 1,000 pounds that we borrowed times $1.50 per pound, the spot exchange rate, pounds per dollar. Dollars per pound. So we're going to have $1,500 to carry over to the US and invest at that 8% rate. How many dollars do we end up with at 8% interest? Well, we take the $1,500 now and multiply that times 1 plus the US interest rate. Notice I use cell references whenever possible. Yeah, I could just type in 1.08 here, but I'd rather use a cell reference. It helps me A, not make as many calculation mistakes, and B, if I wanted to run this scenario again with 2 different interest rates up here, all I would have to do is change these interest rates and wouldn't have to run the formulas again. That's one of the beauties of using cell references. Okay, so I end up with $1,620 having invested it at 8% in the US. But now remember, I want to lock in my pound, I want to lock in my dollar to pound exchange rate right now, so I'm going to sell that money, the $1,620, forward at my forward rate. So I've got $1,620. I'm selling it forward at, well, it's $1.52 per pound. Let's think about the exchange rate. Let's think about the cross rate. What's the pounds per dollar? And that's what I've done here. So here I'm going to multiply it by this cross rate. Remember, the cross rate is just the reciprocal. These two numbers are reciprocals of each other. So I'm going to plug in the cross rate. I get 1,065.79 pounds. And now I'm going to take the sum. Remember, I made this number negative. So now if I just sum them up, we can see what we come up with. And we come up with about 8 pounds. And that doesn't seem like a whole lot. And maybe that might not be enough to justify the transactions cost of this whole procedure. But nonetheless, there's hypothetically a profit opportunity on the table. If we did a million pounds, or maybe 10 million pounds, well, we'd be multiplying that by 1,000 or 10,000. So yeah, there could be several $1,000s of profit potential in doing this exercise. So if you had the means of borrowing and then investing, you could potentially pursue this. It's risk-free. It's pure arbitrage profit if all the numbers work out, and here they indeed do. Okay, so what's going to happen as a result of entrepreneurs and traders, currency traders, seeking this profit opportunity? Well, this is kind of what I'm explaining here in this text box. So what do we have here? It says if U.S. interest rates are higher than UK interest rates, investors will want to sell pounds and buy dollars to invest dollars at the higher U.S. interest rate. And you might remember in the lecture I showed the supply and demand curve shifting. I left that out of here because it makes the model pretty darn complicated. But we know we can jump to kind of the conclusion of this. The spot value of the dollar in terms of pounds will go up, because people want more dollars. There's going to be an increase in the demand for dollars, and people are paying for them with pounds. So the value of the dollar in terms of pounds will go up. Okay, the value of the dollar in terms of pounds will go up. Now I'm going to be looking at the cross rate. I'm looking at the pounds per dollar rates here. I'm going to go ahead and highlight these because I want to think about now the pounds per dollar version of the rate rather than the dollars per pound. For this to go up, the spot dollars per pound is going to go down, right? So we want to remember that. This is going to go down, so this can go up. Now, what's the second half of this? To lock in arbitrage profits, people want to sell dollars forward. That means there's more supply of dollars being sold against pounds on the forward market. More supply is going to bring that price down. The forward value of the dollar, and again, it's the dollar in terms of pounds, will go down. So let's summarize here. The pound, in the spot market, the pound price of the dollar is going to go up, but in the forward market, the pound price of the dollar is going to go down. So this is what these are the changes that we're going to be looking for. So this time we're also going to manipulate the spot and forward prices. Now, all the math is going to be the same, isn't it? So let's do that. Let's not run those functions again. I mean, I want you to learn the functions, but I don't want to just have you sitting here and typing. So let's use Excel's power. I'm going to copy that whole thing, make sure I paste it in the right spot. And notice when I copy and paste, by the way, I can copy a whole range here. Then when I want to paste it, I only have to tag the top left corner of where I want it to paste, and it'll kind of unfold from there to the right and down. So hit Control V, and I've got the exact same stuff going on here. And notice now that because my cell references, because my tables are spaced out the exact same way, my cell references have all moved down. So I'm working now with these exchange rates. So if I change these exchange rates, I'm going to change the results down here. Okay, so what did we say? The spot price of the pounds in terms of the pounds per dollar is going to go up. That means dollars per pound is going to go down. So I'm going to just take it down a penny to see what happens. Wow, that alone almost took out all that arbitrage profit. Now it's down to 68 cents. It's pretty much gone. Let's the forward price, and notice that the spot pounds per dollar did go up a little bit. We can't see it here. It went up just a hair. Yeah, it was 0.6667 and now it's 0.6711. We have to show more decimals to actually see that. Small moves. Remember, foreign currencies are quoted to 4 decimals. Very small moves. Often all that's needed here. Okay, what about the forward price? If we're going to expect the pound price of the dollar to go down, that means the forward, that dollars per pound, is going to go up. Let's make that go to 1.53. And yep, we can see that the pound price of the dollar went from used to be 0.66, now it went down to 0.65. And again, we could show more decimals here if we wanted to, as predicted. And look what happened to our arbitrage profits. Now they're negative, so that means they're gone. Nobody's going to keep doing this because you would actually lose money here. You'd lose pounds once you brought them back at the altered forward exchange rate. All right, so that is what our covered interest parity arbitrage process is. And then based on the economics of the impact that's going to have on exchange rates, this is how it gets resolved and the arbitrage gets eliminated. Also has effects on the interest rates. We could build a more complicated model where we also change the interest rates. We could change all these prices together, but you get the idea. The quest for profits by entrepreneurs in the market, and there's lots of them out there, will eliminate arbitrage opportunities. And that's the important thing to remember for now. That's true in foreign exchange markets. That's true if you're selling Beanie Babies on eBay. Profit opportunities tend to evaporate when you have thick markets with lots of competition. Okay, so there we go, wrapping it up for our basic foreign exchange exercises. So it should be in a good position to complete homework 2. I'll see you next time with a tutorial for homework 3.